In a moment shorter than a blink, everything was born. Space, time, matter, and the possibility that you are listening to this now. This audiobook accompanies you on a relaxing journey through the most fascinating facts of the universe. Starting from that first second when everything began, from invisible explosions of pure energy to the atoms that make up your body, each fact reveals how everything emerged from nothing. And while you rest, your mind glides through the secrets of the cosmos one by one. Let's visualize the universe as a completely deflated balloon. During that first second, the balloon began to inflate in an incredible way, as if it were absorbing all the energy and matter that existed. This process, known as the Big Bang, was not an explosion in the conventional sense, but rather a rapid and chaotic expansion of space. But what triggered all this? Why did everything suddenly begin to change in an infinitely small moment? The answer to this question remains an enigma that scientists are trying to decipher. But what we do know is that before the Big Bang, there was nothing as we understand it. There was no time, no space, no matter, just an infinitely dense and hot point. Imagine a tiny point that contains all the energy of the universe. That is the essence of the Big Bang. How can something so small contain so much? During the first second, the conditions were extreme. The temperature was so high that elementary particles such as electrons and quarks were in constant struggle to separate and form matter. The energy vibrated in a way we have never experienced again. But how does this energy translate into the real things we can see and touch? Scientists have proposed that as it cooled, this energy began to combine and form the first particles. Imagine atoms as small pieces of a puzzle that were initially scattered, but as the universe cooled, they began to fit together. In this way, within seconds, the foundations were laid for what would later become stars, planets, and eventually us. One of the most fascinating aspects of the first second is how the fundamental forces of the universe were established. Gravity and nuclear forces began to take shape, determining how particles would interact with each other. Think of gravity as an invisible magnet that pulls things toward it. Without these forces, the universe would be a completely different place. But what would have happened if these forces had not formed as they did? While all this was happening, time itself was also in its infancy. How do we measure time in a universe that is still in gestation? Scientists use something known as Planck time, which is the smallest measurable unit of time. It's like trying to measure time in an instant so brief that it seems almost non-existent. However, in that instant, time began to flow, marking the beginning of everything. So in that first second, how did the energy of the Big Bang become tangible matter? During those early moments, energy transformed into subatomic particles. And these particles grouped together to form the first atoms. Let's imagine we are cooking a recipe. First, we need the ingredients, the energy, to then combine them and obtain the final dish, the atoms. Without that first step, none of what we have would exist. The theory of inflation also plays a crucial role in our story. This idea suggests that, in a fraction of a second, the universe expanded at an incredible speed, much faster than light. This phenomenon is like inflating a balloon almost instantaneously. As the universe expanded, the small irregularities that formed in the matter became the seeds of the galaxies and cosmic structures we know today. But what implications does this expansion have for our understanding of the cosmos? Cosmic background radiation is another legacy of that first second. This radiation is like a distant echo of the Big Bang, a remnant that we can still detect today. The importance of this radiation cannot be underestimated, as it provides us with clues about the composition and evolution of the universe. It's like listening to a recording of an event that occurred billions of years ago, a window into the past. As we reflect on this first second, an intriguing question arises. How did water form on our planet? The story of water on Earth is intertwined with the events of the Big Bang and the evolution of the universe, the formation of oceans. Rivers and lakes is not just a terrestrial phenomenon, but a reflection of cosmic processes that date back to those early moments. From the origin of water, we can follow a thread that leads us to comets and meteorites. These celestial bodies are considered the time capsules of the solar system, carriers of water and organic compounds that may have contributed to the creation of life on our planet. Imagine these cosmic travelers crossing space, bringing with them the necessary ingredients for life. The mystery of that first second is just the beginning of a story that unfolds over billions of years, from the birth of the universe to the formation of Earth. Each stage is interconnected. Human curiosity drives us to keep seeking answers, to explore how those initial moments have shaped our present and potentially our future. What else does the universe hold in its infinite vastness? The quest for knowledge continues, inviting us to be part of this amazing cosmic narrative. What could provoke such a monumental explosion that would give rise to everything we know? The Big Bang, that initial explosion that left an indelible mark on the history of the universe, is the fascinating topic we will explore now. In an instant, what was once an infinitely small, hot and dense point transformed into a vast, expanding universe. But how did this happen, and what does it really mean? To understand the Big Bang, it is helpful to imagine a balloon. When we inflate it, each part of the surface moves away from the others. Similarly, the universe is expanding from that first explosive moment. But what was there before this explosion? The answer is perplexing, as there was actually no before in the conventional sense. Before the Big Bang, neither time nor space existed as we know them. All the elements of the universe were contained in a singularity, a point that seemed to defy our understanding. The explosion of the Big Bang was not a deafening sound or a series of fireworks. It was a rapid and violent expansion that began to create space and time. In the blink of an eye, energy began to transform into subatomic particles, the building blocks of matter. But how long did this take to happen? In the first second of the universe, events occurred that would lay the groundwork for everything that would come afterward. In that first second, the universe transitioned from being extremely hot to cooling enough for particles to start joining together. Light, heat, and energy became protons, neutrons, and electrons. It was as if all the pieces of a puzzle began to fit together, forming the foundation of what would become atoms. But have you ever wondered what role fundamental forces played in this process? From the very beginning, gravity, electromagnetism, and nuclear forces began to take shape, shaping the behavior of particles and the structure of the cosmos. The expansion of the universe did not stop after that first second. Edwin Hubble, a pioneering astronomer, demonstrated that galaxies are moving away from each other, as if the universe was stretching like chewing gum. This discovery revolutionized our understanding of the cosmos and led us to ask, how far will this expansion go? The answer is that the universe could continue to expand indefinitely, raising profound questions about its ultimate fate. Amid this expansion, matter began to develop. But how were the first atoms formed? The energy from the Big Bang, as it cooled, allowed protons and electrons to combine to form hydrogen atoms. These atoms would be the fundamental building blocks of the stars and galaxies that would come later. Imagine a vast ocean of hydrogen where the first stars began to shine, illuminating the darkness of the primordial universe. However, things did not happen in a linear fashion. The inflation theory suggests that in the early moments, the universe experienced an extremely rapid expansion, much faster than what we observe today. What implications does this have? It helps us understand why the universe is so homogeneous and uniform on a large scale, despite the irregularities we see on a smaller scale. Once the universe stabilized, cosmic background radiation began to emerge. This echo of the Big Bang is like a fossil of light that allows us to look back in time. Analyzing this radiation offers us clues about the composition and evolution of the universe. It's as if we have a time machine that lets us glimpse the first moments of existence. As time went on, questions arose about how water formed on our planet. Could it be that water originated from comets and meteorites that collided with primitive Earth? The search for answers to this question leads us to explore the role these objects played in creating a suitable environment for life. The formation of the solar system is also a fascinating story. From a cloud of gas and dust, The planets began to take shape. But what impact did the collision that gave rise to our moon have? This catastrophic event not only resulted in our natural satellite, but also shaped the Earth and its climate in ways we are still trying to understand. And so the universe, with its vast expansion and intricate mysteries, raises questions about life on other planets. Are there other worlds with water and therefore the possibility of life? In the search for answers, we explore not only our solar system, but also distant exoplanets that might harbor conditions similar to those that allowed life on Earth. As we reflect on these topics, we find ourselves in a constantly changing universe. From the evolution of hurricanes to climate predictions, each phenomenon reminds us that we are part of a dynamic and evolving cosmos. The story of the Big Bang is not only the beginning of the universe, but also an invitation to continue exploring the unknown. In this vast stage, we find ourselves as small actors, trying to understand our place in a universe that, though immense and mysterious, also connects us in surprising ways. If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey. Have you ever thought about the vast and mysterious universe that surrounds us? In its immensity, there is a phenomenon that has left scientists and curious minds around the world in awe: the discovery that the universe is expanding. But what does this really mean? Imagine that the universe is a balloon. When you inflate the balloon, every point on its surface moves away from the others. This is how the universe behaves, and Edwin Hubble was the pioneer who helped reveal this astonishing truth. In 1921, Hubble observed that galaxies are not static, they are moving away from us. The farther away a galaxy is, the faster it is receding. This was a revolutionary finding that changed our understanding of the cosmos. But what caused this expansion? The answer lies in the Big Bang, an event that occurred about 13.8 billion years ago. This was not just a simple explosion, but a monumental event that gave rise to all the matter, energy, space, and time that we know. When talking about the expansion of the universe, it is essential to understand that it is not just about objects moving in empty space. In reality, space itself is stretching. Imagine you are at a party with a bunch of balloons in the room. If one of those balloons is inflated, it not only gets bigger, but also creates more space between the other balloons. That is exactly what happens with galaxies in our universe. The space between them is constantly expanding. But how do we know that this expansion is underway? Hubble used an ingenious method by observing the light spectrum of galaxies. When an object moves away from us, the light it emits shifts toward the red, a phenomenon known as redshift. If you have ever heard an ambulance siren moving away, you may have noticed that the sound becomes lower in pitch. This is similar to what happens with the light from galaxies. Hubble detected that almost all galaxies showed this effect, confirming that they were moving away. However, the expansion of the universe raises intriguing questions. How far will this expansion go? The answer is full of mystery. Some scientists believe that the universe will continue to expand forever, while others suggest that it could stop and begin to contract. This paradox leads us to question the very nature of the universe. Are we alone in this vast space, or are there other universes that are also expanding? As we continue to explore, we encounter fascinating concepts like dark energy, which is believed to drive this accelerated expansion. Although dark energy remains an enigma, its presence is felt in every corner of the universe. Imagine it as an invisible force pushing galaxies farther apart, as if the universe were in an endless race. We often wonder what the universe will look like in millions of years. What will happen to the galaxies that are so far away from us? Some of them may become so distant that their light will never reach us, leaving us with unanswered questions about what lies beyond our cosmic horizon. This idea leads us to reflect on our own existence and our place in the immense tapestry of the universe. The expansion of the universe also invites us to think about time. Since the moment of the Big Bang, time itself has been in constant evolution. In the early moments of the universe's existence, the laws of physics as we know them did not apply. Expansion and time are intertwined concepts, and understanding one involves exploring the other. It is fascinating to think that the universe is in a state of perpetual change. Every galaxy, star, and planet is on a journey through time and space. Expansion is not just a physical phenomenon, it is also a reminder that the universe is alive and in constant transformation. This leads us to wonder what future awaits our home Earth in the midst of this vastness. As we advance in our exploration of the universe, let us remember that each discovery brings us a little closer to understanding the complexity of our existence and the role we play in this immense cosmic stage. The expansion of the universe is not just a scientific fact, it is a reminder of the wonder and mystery that surrounds us, challenging us to keep seeking answers to the questions that still remain to be asked. What is the secret behind the forces that hold our universe together? From the moment the Big Bang initiated creation, fundamental forces began to play a crucial role in the organization of matter and energy. Imagine a scenario where everything we know is formed from invisible interactions that shape reality. In the first second of the universe, these forces began to emerge, shaping the cosmos as we know it. Gravity, for example, is one of these fundamental forces. Think of it as a giant magnet that pulls everything toward the center of the Earth. Without gravity, planets could not orbit stars and we would not be here, firmly planted on the ground. But how did this vital force originate? In the early moments after the Big Bang, the universe was a soup of extreme energy. As this energy began to cool, the first components of gravity started to form, establishing a framework that would allow for the creation of massive structures, such as galaxies and stars. But gravity is not alone. There are other forces that also came into play, such as nuclear forces. Imagine you are at a party where all the guests are atoms. Some of them feel so comfortable with each other that they decide to join together and form something larger, like a molecule. Nuclear forces act like the glue at this party, keeping the nuclei of atoms together. Without them, there would be no way for elements to bond, and thus matter as we know it would not exist. Now, what about the electromagnetic force? This is what allows electrons to orbit around the nucleus of atoms. Like planets in orbit, the electromagnetic force is responsible for electricity and magnetism, and it plays a fundamental role in the creation of all kinds of matter. If the universe were a huge stage, the electromagnetic force would be the director organizing all the actors in a cosmic dance. All of this happened in an incredibly short period of time, just a moment. How can we measure something so fleeting yet so crucial? This is where the notion of Planck time comes in. This is the smallest time we can measure, and it is the point where quantum mechanics and gravity meet. In that first second, Planck time dictated the rules of the game, allowing energy and forces to begin interacting in ways that would lead to the creation of the universe. It is fascinating to think that everything we see around us, from the bright stars in the sky to the rocks beneath our feet, originated in those initial moments. But what happened after that initial explosion? As the universe continued to expand and cool, the fundamental forces began to solidify, creating a delicate balance. This balance is what allows life to exist on our planet. However, what would happen if any of these forces did not exist? Imagine a universe without gravity. Everything would flow freely, and there would be no planets, stars, or life. Or think of a universe without the electromagnetic force. Atoms could not bond, and matter as we know it would not exist. The fundamental forces are the invisible threads that weave the fabric of the universe. And their emergence in that first second was the key to everything that would come afterward. The creation of these forces also raises intriguing questions. Could we ever manipulate these fundamental forces? As science advances, scientists explore ways to understand and, in some cases, control these forces. Future technology could allow us to play with the very laws that shape the cosmos. At this point, it is important to reflect on our place in this vast universe. We are the product of those early interactions, of the energy and matter that combined to give rise to life. Each of us is a small corner of the universe, a testament to the incredible dance of the fundamental forces that began in that first second. With each scientific discovery, we get a little closer to unraveling the mysteries of the universe. Each new advancement in physics offers us a new perspective on how fundamental forces shape our reality. So when we look up at the starry sky, we do not just see points of light, but the result of a complex web of interactions that began billions of years ago. The story of fundamental forces is a story of creation and transformation. From the chaos of the Big Bang to the ordered structure of the current universe, these forces have been crucial in the development of everything we know. Thus, in every corner of the cosmos, there is a reminder of that first second, a moment that marked the beginning of everything we are and everything that surrounds us. Time, that entity that seems to flow constantly around us, has a beginning as fascinating as the universe itself. When we talk about time in the context of the Big Bang, we encounter a surprising reality. Time as we know it did not exist in the early moments of the universe, but how is it possible that something as fundamental as time was not present? The answer to this question leads us to understand the concept of Planck time. In the moments following the Big Bang, the universe was an extremely hot and dense place. In that environment, not only was matter in a primordial state, but the physical laws we know today were different. Time, in this context, is described in ways that challenge our everyday understanding. Planck time, which lasts approximately 10 to the power of -43 seconds, is the first moment where we can speak of time. But what does this mean exactly? Imagine a clock that measures time on an infinitesimally small scale. In that first second, time moves at a speed that is almost impossible to imagine. In fact, it is so short that we cannot perceive it with our senses or measure it with our current instruments. But why is this Planck time important? The answer lies in the fact that in those brief moments, the universe was taking shape, laying the foundations for what would come next. Some might wonder, what happened during those instants? The energy was so concentrated that it was impossible to distinguish between time and space. In this primal state, matter and energy were intricately intertwined. The idea that time is a continuous line crumbles in this context. Rather, time and space were like a blank canvas, ready to be painted with the events that would shape our universe. But how can we visualize something so abstract? Think of a movie that has a sequence of still images. Each image represents a moment in time. Now imagine that those images are so close together that you cannot distinguish one from another. In that first second, the universe was like a movie where each frame was so tightly packed that they merged into a single vibrant image of pure energy. As the universe began to expand, time started to take shape, particles began to separate, and the universe started to cool. This process is crucial because as time progressed, it led to the creation of the first fundamental structures of matter. But what does this mean for us today? The notion of time also leads us to reflect on how we measure our lives. Why, however, is Planck time still so difficult to understand? In our daily lives, we measure time in seconds, minutes, and hours. However, those units are minimal compared to Planck time. Still, Planck time is essential for understanding the physics of the universe, as it helps us grasp the beginning of everything. What if there were no limit to time? Could we imagine a universe where time was not a constant? In this sense, Planck time serves as a reminder that time has its origin, a starting point that challenges our most basic concepts. In the vast stage of the cosmos, this tiny instant is what allowed everything we know to emerge from nothing. Is it possible that time as we know it evolves and changes over time? Some theories suggest that time could be more flexible, more dynamic than we think. This leads us to consider not only Planck time, but also how our understanding of time may transform as we explore the universe further. With each passing second, the universe continues to evolve, and time keeps moving forward. However, that first second remains a mystery that captivates scientists and philosophers alike. It invites us to question not only the nature of time but also our own existence in this vast cosmos. As we reflect on the creation of time, we also confront the deepest question of all. What is our place in this intricate fabric of the universe? The exploration of time, from its inception in the Big Bang to its manifestation in our daily lives, connects us with the past and invites us to imagine the future. It reminds us that every moment counts and that, although time may seem like an endless river, it has its roots in a primordial instant. This instant is the spark that ignited the flame of the universe, a reminder that time is both a physical concept and a human experience. So the next time you look at the clock, remember that time, in its purest essence, began in an instant so brief that it defies all perception. Since that first second, the universe has been in constant evolution, and we, as part of it, are witnesses to its marvelous journey. The story of time is the story of everything we are and everything we will be. The story of our universe begins in an almost incomprehensible instant. In what is known as the Big Bang, an explosion of pure energy gave rise to everything we know. But how does that energy turn into something tangible, like the atoms that make up everything around us? To understand this, we must unravel the fascinating process of matter creation. First, imagine an ocean of dense, hot energy. In this primordial sea, the temperature was so high that matter, as we know it, could not exist. However, as the universe began to expand, that energy started to cool down. What would happen then? In that cooling process, energy began to transform into particles. But what are these particles? Essentially, they are the fundamental building blocks of everything we see around us. At first, subatomic particles such as quarks and electrons formed. But what makes these particles come together? The answer lies in the fundamental forces of nature. Just as a magnet attracts other metallic objects, nuclear forces began to act, binding these quarks to form protons and neutrons. Thus, in the blink of an eye, matter was taking shape. But what happened next? With the formation of protons and neutrons, the next step was the creation of the first atomic nuclei. But how did that step occur? This is where the temperature and pressure of the universe play a crucial role. As the universe continued to expand and cool, these particles began to combine to form the nuclei of hydrogen and helium. However, why only these two elements? The answer lies in the extreme conditions of the universe at that time. Now we might ask, what about the electrons? Where do they fit into this story? As the universe continued to cool, the energy became low enough for electrons to join the hydrogen and helium nuclei. Suddenly, we had the first atoms, but this was just the beginning of a long process. How is it possible that those atoms became the stars and galaxies we see today? The first atoms took hundreds of thousands of years to form more complex structures. During that time, the universe filled with a haze of gas and dust. But how did that haze transform into the stars that light up our sky? Thanks to gravity, the same force that keeps our feet on the ground began to attract those small accumulations of gas, forming dense clouds that eventually collapsed under their own weight, giving rise to the first stars. At this point, the story of matter becomes even more interesting. Stars, by fusing hydrogen and helium, began to produce heavier elements such as carbon, oxygen, and iron. But how did these elements become part of us? When the largest stars reached the end of their lives, they exploded in spectacular events known as supernovae, scattering these elements throughout the universe. Thus, stardust began to form new solar systems like ours. And here arises an intriguing question. Can we see the reflection of this process in our own bodies? The answer is an astonishing yes. The atoms that make up our being are mostly the same ones that were created in those first stars. In fact, every time we inhale, we are breathing in the same atoms that existed millions of years ago. So, in a sense, we are part of the universe's story. As we move forward in this narrative, it is essential to remember that the process of matter creation was not instantaneous. It required millions of years of cosmic evolution. But why is it important to understand this process? Knowing our origins helps us comprehend our connection to the universe and our place within it. the story of matter is also a story of transformation. From those first subatomic particles to the complex atoms that make up everything we see, the journey is astonishing. But what does the future hold for us? As scientists continue to explore the vast universe, new questions arise. Will there be more surprises on our path to understanding matter and the universe? Finally, when reflecting on the creation of matter, we find ourselves facing a vast and mysterious cosmos, where every atom tells a story. The matter that surrounds us, that forms our bodies and the world we know, is the result of processes that began billions of years ago. So every time we look up at the stars, let us remember that we are looking into our own past and that we are part of a story much larger than we could ever imagine. The theory of inflation is one of the most fascinating ideas that has emerged in our quest to understand the universe. But what exactly is this inflation? To understand it, we must first think about the moment everything began. In that first second after the Big Bang, the universe was not only expanding, but it was doing so at an incredibly rapid pace. Imagine you are inflating a balloon. At first, it seems small, but in an instant, boom, it expands far more than you could have imagined. That was the universe in its early moments. During this period of inflation, it is believed that the universe expanded at a speed greater than that of light. Can anything move faster than light? According to our current physical laws, no. However, inflation is not about an object moving through space, but rather space itself expanding. This is what makes inflation so intriguing and challenging to imagine. That tiny point that was the entire universe became a vast space that continues to grow. But what caused this rapid expansion? Scientists suggest that it was a form of energy referred to as the inflationary field that dominated the universe at that primordial moment. This field had an incredible force, like a kind of cosmic engine. However, the curious thing is that we do not fully understand how it worked. It is like trying to decipher a puzzle where the pieces seem not to fit together completely. Inflation not only explains how the universe expanded, but it also has implications for the uniformity we observe today. Why is it that despite the universe being immense, galaxies and radiation are so similar in different directions? The theory of inflation suggests that in its early moments, different parts of the universe were in contact, and that rapid expansion helped to smooth out the differences, as if you were flattening a rough surface. Moreover, inflation can answer an intriguing question. Where do the structures we see in the universe, such as galaxies and clusters of galaxies, come from? During inflation, small quantum fluctuations in that inflationary field became the seeds of those structures. These tiny irregularities created in the early universe have been amplified over time, giving rise to the complexity we observe today. A useful analogy would be to think of a field of flowers. Initially, all the flowers are small and similar, but as time passes and the right conditions are met, some grow faster than others. This is how the differences in the universe began to take shape. The fluctuations in the inflationary field became the seeds that would germinate into the galaxies we know today. But what about the future? The theory of inflation also invites us to think about what could happen in the universe. If the universe continues to expand, could there be more inflations in the future? Could we be in one of many universes, each with its own inflation story? This idea, known as the multiverse, raises questions about the nature of reality that are both exciting and perplexing. As we delve deeper into these theories, it is fascinating to realize that our understanding of the universe is constantly evolving. Each discovery leads to new questions and new possibilities. What else does the cosmos have in store for us? What other wonders lie in the corners of space that we have yet to explore? The theory of inflation is just one chapter in the cosmic story we are beginning to write. Each advance in science brings us a little closer to answering questions that have puzzled humanity for centuries. The more we learn, the more we realize how much we have yet to discover. Ultimately, inflation not only helps us understand the past of the universe, but also allows us to glimpse its future. It is a reminder that Although we may feel small in the vastness of the cosmos, we are part of a grand and ongoing story. Human curiosity is what drives us to seek answers, and each discovery is a new piece of the puzzle of the universe. So the next time you look up at the starry sky, remember that every star, every galaxy, and every corner of space has its own story to tell. Inflation was just the beginning of a cosmic journey that continues at this very moment. There is so much more to discover, and each of us has a role in exploring this vast and intriguing universe. What does the universe really tell us about its birth? As we look up at the stars, there is an echo of a distant time, a time filled with mystery and energy. This echo manifests itself in the form of cosmic background radiation, a kind of whisper from the Big Bang that still resonates in the space around us. But what does this mean, and why is it so important? Visualize a moment after the Big Bang occurred. The universe was like a sea of energy. Everything was light and heat. As the universe began to expand, that energy started to cool. Over time, subatomic particles formed, and eventually the first atoms. But something fascinating happened in that process. The radiation created in those early moments can still be detected today. It's as if the universe is sending a message through time, and we, with our telescopes and tools, are trying to decipher it. Now, imagine the universe as a huge balloon that is inflating. As it expands, the light traveling through it stretches, creating what we know as cosmic background radiation. This radiation can be compared to the echo of a great explosion. And the best part is that it is not just there, it is tangible proof of our origin. But how do we know that this radiation is truly a remnant of the Big Bang? Scientists have worked tirelessly to measure this radiation. By observing it, they have found that it has an average temperature of just 2.7 degrees above absolute zero. This may seem cold, but in the vast cosmos, it is a sign that the universe has been constantly cooling since its initial explosion. The way this radiation is distributed in space also gives us clues about the structure of the universe itself. Who would have thought that something so ancient could tell us so much? An intriguing aspect of cosmic background radiation is its uniformity. It's as if the universe was designed with astonishing delicacy. However, there are small variations in this radiation, and those tiny differences are what have allowed for the formation of galaxies and stars. Imagine those variations as small imperfections on a canvas, which, instead of ruining the artwork, allow a beautiful landscape to emerge. But what about its importance in the search for life on other planets? Cosmic background radiation not only speaks to us about our past, but also has implications for the future. By understanding the history of the universe, we can begin to formulate questions about the creation of other planetary systems. Could other worlds have witnessed similar events? Could they also harbor life? As we explore space further, cosmic background radiation becomes an invaluable tool. It helps us map the history of the universe, understand how the structures we see today have formed, and thus project what the future of the cosmos might be. Every time we look up at the sky, we realize that we are part of a much larger story. The theories about the origin of cosmic radiation also lead us to question the future of our own planet. Are we alone in this vast universe? The answer might be hidden in that radiation. The study of how water formed on Earth, for example, may be linked to the conditions that existed in those early moments of the universe. In this sense, cosmic background radiation is not just an echo of the past, but also a promise of future discoveries. Human curiosity drives us to keep seeking answers. Cosmic background radiation is just a hint, a clue in a cosmic game of hide and seek. What else can we discover by studying these echoes of the past? Each new discovery opens the door to more questions, and each question brings us a little closer to understanding our place in the universe. However, the journey doesn't end here. As we advance in our exploration, it is essential that we keep an open mind. What we know today could change tomorrow. Science advances by leaps and bounds, and with each advance, Our perceptions of cosmic radiation and its impact on the cosmos expand. Curiosity is the engine of progress, and every answer we find generates more questions. Ultimately, cosmic background radiation is a reminder of our connection to the universe. It shows us that we are part of a larger whole and that despite distances and time, we are intrinsically linked to the events that occurred billions of years ago. Every time we look at the sky, we remember that we are the result of an epic story, woven in the vastness of space. So the next time you pause to contemplate the stars, think of cosmic background radiation as a whisper from the universe, an echo of its infancy. The quest to understand it never ends, and each discovery brings us one step closer to unraveling the mystery of our origin and the future that awaits us. Where does the water that covers most of our planet come from? This question has intrigued scientists and curious minds alike for centuries. Water is essential for life as we know it, but its origin remains a mystery. Could it be that our oceans are the result of a great event in the past, or perhaps a series of cosmic occurrences? One of the most exciting theories suggests that water arrived on Earth through comets and asteroids. Imagine a dark sky where small celestial bodies travel at high speeds, colliding with Earth in a cosmic dance. These space travelers, rich in ice, may have brought with them the water that now forms our oceans. But how do we know this is possible? Comets are like time capsules carrying the secrets of the primitive solar system. They are primarily made of ice and dust, and when they approach the sun, they release gases and particles, creating those stunning bright tails that we admire. If these comets collided with Earth in its early years, they could have left large amounts of water, but they are not the only culprits. Asteroids may also have played a crucial role. Primitive Earth was an inhospitable place, full of volcanic activity and constantly bombarded by these celestial bodies. As the planet cooled, the water vapor in the atmosphere began to condense, forming the first raindrops. But how long did it take before these oceans began to fill? Some scientists believe that this constant rain could have lasted millions of years, creating an environment conducive to life. However, not all the water we have today comes from these collisions. There is another theory that suggests some of the water may have formed within the Earth itself. Like a pressure cooker, the extreme heat and pressure inside the planet could have allowed hydrogen and oxygen to combine, forming water. But what about the water on other planets? The search for water in space has led scientists to investigate Mars, Europa, and Enceladus, moons of Jupiter and Saturn, respectively. These icy worlds are covered in ice and may harbor hidden oceans beneath their surfaces. If life could arise here on Earth, what are the chances that there is also life in those distant worlds? The search for water does not stop in our solar system. Astronomers have found exoplanets in habitable zones where conditions could be favorable for liquid water. This opens the door to fascinating questions. Could there be life in other corners of the universe? What forms might it take? As we explore these possibilities, we must also consider the pure chemistry of water. This substance is unique in its ability to dissolve almost everything, making it an ideal solvent for the chemical reactions that sustain life. From the water flowing in our rivers to the deep oceans, its presence is fundamental to biology. But how much do we really know about its behavior? The water cycle is an amazing phenomenon that keeps this vital resource in constant motion. Water evaporates from the oceans, condenses in clouds, and returns to Earth as rain or snow. This cycle is not only essential for life, but also regulates the planet's climate. Yet, despite its omnipresence, water remains a limited resource. And this is where conservation becomes crucial. As Earth's population grows, the demand for water increases. Droughts, pollution, and climate change threaten our water supplies. The question becomes urgent. What can we do to protect this vital resource and ensure that future generations have access to clean and safe water? As we reflect on the origin of water on our planet, we must also consider its deeper significance. Water is not only the foundation of life, it is also a symbol of renewal and change. Throughout history, it has been a source of inspiration, mythology, and spirituality. From the ancient civilizations that settled by great rivers to the present day, water has been a central element in the human experience. In summary, the water on Earth is the result of a series of cosmic events and chemical processes that have occurred over billions of years. Its origin, though still shrouded in mystery, reflects the complexity of the universe and the delicate balance that sustains life. As we embark on the quest for answers about other worlds, we must also value and care for the water we have here, in our home. Since time immemorial, humanity has looked to the sky, marveling at its vastness and seeking answers about its own existence. One of the great questions we ask is, where does the water on our planet come from? It is a mystery that has intrigued scientists and philosophers alike. To understand how the oceans formed, we must travel back in time to the origins of Earth, a journey that will take us to explore comets and meteorites. Comets, those icy travelers of space, are primarily composed of ice, dust, and gases. They could be considered the messengers of the primitive solar system. Imagine a huge block of snow traveling through the cosmos. As they approach the sun, their ice evaporates, forming a beautiful tail that shines in the sky. But beyond their beauty, comets carry a secret. They contain water and other essential compounds for life. The story begins with the birth of the solar system. About 4.6 billion years ago, a cloud of gas and dust began to collapse under its own gravity, giving rise to our sun and the planets that surround it. In this chaotic environment, comets and asteroids began to form, bringing with them the possibility of delivering water to Earth. But how did they get here? The most accepted theory suggests that during the formation period of Earth, our planet was subjected to intense bombardment by small celestial bodies. Asteroids and comets wandering through space collided with Earth in a phenomenon similar to a cosmic rain. It is estimated that these impacts were responsible for delivering large amounts of water, as well as other elements and chemical compounds that were crucial for the development of life. Imagine for a moment that each of these impacts was like a drop of water that upon falling filled a huge empty container. At first, Earth was an inhospitable place, a ball of fire and lava, but over time, as the impacts accumulated water, the oceans began to form. But that's not all. The story of water on Earth is also a story of transformation. Meteorites, those fragments of asteroids that survive the journey through the atmosphere, have also played a fundamental role. These celestial bodies contain not only water, but also amino acids and other compounds that are the building blocks of life. So, in a sense, we could say that life on Earth has an extraterrestrial origin, as these seeds came from space. As the planet cooled and water began to accumulate, the first oceans formed. But what happened next? The interaction between water, the atmosphere, and the Earth's surface began to create an environment conducive to life. The changing conditions and the presence of essential elements led to the emergence of unicellular organisms in the water. Thus, the cycle of life began. The search for water on other planets has led humanity to explore the solar system. Mars, for example, has been the subject of numerous studies. Scientists have found evidence of ancient rivers and lakes, suggesting that at one time the red planet had water on its surface. But could there be life on Mars? That question remains unanswered. The search for water is not limited to Mars. The moons of Jupiter and Saturn, such as Europa and Enceladus, have also shown signs of hidden oceans beneath their icy layers. This has led the scientific community to speculate that if there is water, some form of life could exist on these distant worlds. Imagining the possibility that we are not alone in the universe is fascinating. But returning to our planet, the existence of water has shaped Earth in surprising ways. Oceans are not only essential for life, but they also regulate the climate and act as a massive reservoir of carbon. Without them, Earth would be a very different place, perhaps inhospitable to life as we know it. As we delve into this exploration of the origin of water, it is important to remember that the journey of discovery continues. Scientists are still researching and launching missions to unravel the secrets of water and its role in the formation of other worlds. The story of water is a story of connection, of how we are all intertwined in the vast fabric of the universe. So the next time you look at an ocean, remember that you are not just seeing water. You are contemplating the result of billions of years of cosmic history, of collisions and encounters, of elements that traveled through space to give life to our planet. Water is a gift from the universe, an essential part of our existence, and a reminder that despite the vastness of the cosmos, we are all connected on this journey through time and space. The solar system, that vast collection of celestial bodies orbiting our star, the Sun, is a fascinating place. But have you ever wondered how it formed? The story of its origin is as intriguing as that of a great cosmic puzzle. To understand it, let's go back billions of years, to a time when Earth didn't even exist. It all began in a giant cloud of gas and dust, a place where gravity worked its magic. Imagine a massive snowstorm. Only instead of snowflakes, there were subatomic particles, hydrogen and helium atoms beginning to clump together. Over time, these tiny particles started to unite, forming what we now know as the solar nebula. But how did this happen? Gravity, that force we feel when we fall, was responsible for pulling all this material toward the center of the nebula. As more and more material accumulated, the pressure and temperature at the center increased. Have you ever wondered what happens when you compress something very tightly? Exactly, it heats up. This is how, at the heart of this nebula, a fundamental process began: nuclear fusion. This reaction released an immense amount of energy, giving life to the Sun, our star. However, the Sun was not alone. Around it, the nebula continued to spin and cool, creating an environment conducive to the formation of other celestial bodies. As the material cooled, small clumps of dust began to stick together. These clumps grew larger and larger, forming what we call planetesimals. Imagine small balls of increasing mass colliding and merging, forming larger bodies. Over time, some of these planetesimals became protoplanets, bodies that, in turn, merged to create the planets we know today. Earth, Mars, Jupiter, and the others all emerged from this process. But how is it decided who is a planet and who is not? It all comes down to gravity. Planets have enough mass to attract other bodies around them, while asteroids and comets are smaller and fail to clear their orbits. Thus, the solar system began to take shape. And Earth, our home, became one of these planets. Each planet has its own unique story. For example, Venus, with its dense and hot atmosphere, is a very different place from Mars, which is cold and dry. And let's not forget Jupiter, the gas giant, which has a huge influence on the solar system due to its massive gravity. In fact, it is said that Jupiter acts like a cosmic vacuum cleaner, attracting objects that could threaten Earth. But planets were not the only things that formed. Asteroids and comets also emerged, smaller bodies that remained along the way. Asteroids grouped in the asteroid belt between Mars and Jupiter, while comets, with their bright tails, wander through the solar system. These comets are true time travelers, as they contain information about the early days of the solar system. The origin of the solar system not only tells us how the planets formed, but also helps us understand our place in the universe. Earth is a privileged planet with conditions suitable for life. But why is it so special? The combination of liquid water, a protective atmosphere, and the right distance from the Sun are crucial factors. There is something surprising in this story. The formation of the solar system was not an isolated event. Other stars in our galaxy have also gone through similar processes. The Milky Way is full of solar systems at different stages of formation, so while we talk about our home in this corner of the universe, there are many other solar systems that are in the process of creation, some of which could harbor life. As the story of the solar system progresses, there is a crucial point we cannot overlook: the formation of the Moon. This story begins with another celestial body that collided with young Earth. That collision was so intense that part of the material from Earth and the object broke off and began to orbit our planet, forming the Moon. This relationship between Earth and the Moon is fundamental, as it affects the tides, the stability of Earth's rotation axis, and thus the climate. The creation of our solar system is a reminder of how extraordinary the cosmos is. Each of us is part of this vast network of matter and energy that has been in constant transformation since the beginning of time. When we look at the night sky, we don't just see stars, we see the history of our solar system, a story that continues to be written with each new generation of astronomers and explorers. So the next time you think about the solar system, remember that it is not just a collection of planets orbiting a star, it is a testament to the complexity and beauty of the universe, a universe that, despite its vastness, has given rise to a place where life can flourish. The story of the formation of our solar system is just a chapter in the book of existence, a book that is still waiting to be written. The formation of the moon is one of the most fascinating stories that can be told about our solar system. Imagine a scenario of cosmic chaos where a young Earth, still hot and in the process of formation, finds itself in the line of fire of a colossal impact. How did this encounter occur that would forever change the future of our planet? It all began about 4.5 billion years ago when a body the size of Mars, called Theia, collided with Earth. This impact was not a mere brush, but a titanic collision that released energy equivalent to millions of nuclear bombs. Have you ever imagined what it would be like to witness such an event? As Earth was struck, it expelled a huge amount of material into space, material that would become what we now know as the Moon. But why is this collision so important? The answer lies in the effect it had on Earth. As the Moon formed, it not only began to orbit our planet, but also influenced its stability. Without the Moon, Earth would have a much more erratic axial tilt, resulting in extreme climates and less favorable conditions for life. So, in a sense, our Moon is a protector, maintaining a balance that has allowed life to thrive. The early days of the Moon were a spectacle of fire and lava. Like an artist shaping their work, the intense heat allowed the Moon's surface to be molded into a landscape of craters and dark seas. Can you imagine what it would be like to walk on such a surface? This hostile environment was the cradle of what would later become the satellite we know today. Gradually, the Moon cooled and its surface solidified. But unlike Earth, which has a rich atmosphere of oxygen and water, the Moon ended up with a very thin, almost non-existent atmosphere. Why couldn't the Moon retain water like our planet did? The answer lies in its lower gravity and the lack of a magnetic field to protect it from cosmic radiation. This combination caused the water on the Moon to evaporate and be lost to space. Over the millennia, the relationship between Earth and the Moon has been fundamental. The gravitational force between the two celestial bodies not only keeps the Moon in orbit, but also influences the tides of Earth's oceans. Did you know that the Moon is responsible for variations in sea level? Without its presence, tides would be much less pronounced, altering coastal ecosystems and marine life. However, the formation of the Moon also brought with it a series of phenomena that have marked the history of Earth. Meteorite collisions, which were more frequent in the early days of the solar system, left their mark on both the Moon and our planet. Each visible crater on the lunar surface is a reminder of these violent encounters. If you look up at the sky on a clear night, each spot on the Moon is telling you a story. Theories about the formation of the Moon have evolved over time, from the capture hypothesis, which suggests that the Moon formed elsewhere and was captured by Earth's gravity, to the giant impact idea, which is the most accepted today. As scientists study samples brought back by the Apollo missions, they are discovering more about the lunar composition and its relationship with Earth. What secrets does the Moon still hold? The relationship between Earth and the Moon is not just physical, it has also influenced human culture throughout the centuries. From ancient civilizations that worshipped the Moon as a deity to poets inspired by its beauty, the Moon has been an inexhaustible source of fascination. How is it possible that a simple satellite can have such a profound impact on our lives? In the scientific realm, the Moon has been a natural laboratory. Space missions have shown that despite its desolate appearance, the Moon has resources that could be valuable for future explorations. Could the Moon be the next frontier in our quest for space colonization? Some believe so, and plans to establish lunar bases are underway. The future of the Moon is also intertwined with the future of Earth. As we advance in space exploration, the Moon presents itself as a starting point for more ambitious missions. The possibility of using it as a platform to explore Mars and beyond is exciting. Are we preparing to turn the Moon into a springboard to the rest of the universe? In conclusion, the formation of the Moon not only represents a fascinating chapter in the history of our solar system, but also serves as a reminder of how cosmic events can have long-term repercussions. The Moon, with its beauty and mystery, continues to be an object of study and admiration. What else will we discover about it in the future? Every time we look up at the night sky, we can remember that the story of the Moon is, in many ways, the story of Earth itself. Can there be life on other planets? This is one of the most fascinating questions we ask as humanity. Since time immemorial, we have looked up at the starry sky wondering if we are alone in the vast universe. But what do we need for life to flourish on another world? In this quest, water emerges as a fundamental protagonist. Water is essential for life as we know it. On our planet, it is the magical ingredient that has allowed organisms, from the simplest bacteria to humans, to thrive. But where can water be found in the universe? There are numerous celestial bodies that could harbor it, from icy moons to exoplanets with promising atmospheres. The cosmos is full of possibilities. One of the most intriguing moons is Europa, which orbits around Jupiter. This icy moon hides a liquid water ocean beneath its surface. The idea that there is water on Europa is exciting, as it could be a place where life, even if microscopic, has the opportunity to exist. Can you imagine the possibility of finding organisms that have lived for thousands of years in a hidden ocean, moving on to Mars? The red planet has captured our imagination for decades. Space missions have revealed that in the past, Mars had wetter and warmer conditions. There are indications of rivers and lakes, as well as ice at its poles. Could there have been life on Mars at some point in its history? The search for answers has led us to send rovers and probes to investigate its surface and look for signs of past life. In the vast universe, we also find exoplanets, those that orbit other stars. Some of them are located in the habitable zone, where conditions could be suitable for the existence of liquid water. Planets like Kepler 186f and Proxima Centauri b are just a few examples that have sparked the interest of scientists. What secrets do these distant worlds hold? Human curiosity drives us to seek answers. The exploration of these places is not limited to the search for water. It is also a journey toward understanding our own origins. Each discovery about the existence of water on other planets brings us one step closer to understanding how life arose on Earth. Are we connected in some way to those distant worlds? Could life have originated in multiple places? But why is water so important? Besides being a universal solvent, water participates in chemical reactions essential for life. It allows the formation of complex molecules and acts as a medium for the transport of nutrients. Without water, life as we know it would not be possible. It is like the canvas on which the story of life is painted. In our search for other worlds, we cannot forget the importance of comets and meteorites. These celestial bodies have been considered possible carriers of water and organic matter. It is believed that comets, which come from the distant regions of the solar system, may have brought water to Earth in its early days. Could these space travelers also have carried the necessary ingredients for life? As we advance in our understanding of the universe, questions also arise about the possibilities of colonizing other planets. If we find water in places like Mars or Europa, could we establish human bases there? The idea of becoming an interplanetary species is not just a science fiction dream, but a goal that many scientists are actively investigating. The study of water on other planets offers us a window into our past and a glimpse into our future. It reminds us that although we are on Earth, we are part of a vast cosmos full of mysteries to discover. The possibility of finding life on other worlds challenges us to continue exploring and questioning our place in the universe. As we look to the future, we must reflect on how we care for our own planet. The search for life on other worlds can be an opportunity to learn how to protect Earth, our home. After all, if we discover that we are not alone, shouldn't we take better care of the life that already exists here? The search for water and life on other planets continues to be one of the most exciting adventures in modern science. Every day, new discoveries bring us one step closer to answering the questions that have intrigued us for centuries. As we explore, let us remember that the desire to understand our place in the universe is what unites us as a species. So as we continue to gaze at the stars and explore the far reaches of our solar system and beyond, let us keep an open mind. Life may be waiting in places we have yet to imagine, and on this journey, each of us can be part of the story we are writing together in the search for other worlds with water and perhaps life. The formation of hurricanes is one of the most fascinating and at the same time terrifying natural phenomena we experience on our planet. What truly brings these powerful storms to life? To understand it, it is essential to know the ingredients needed. Imagine a large pot of boiling water. If you add heat, the water begins to evaporate, creating steam. In the case of a hurricane, the energy comes from the heat of the ocean. When water temperatures are high enough, the water vapor begins to rise, forming clouds. But what happens next? As the vapor rises, it cools and condenses into water droplets, releasing a huge amount of energy in the form of heat. This process is like inflating a balloon. The more air you put in, the bigger it gets. In this case, the additional heat causes the surrounding air to rise even more, creating an updraft. But this is where it gets complicated. How does that air organize itself into a hurricane? The warm air, as it rises, leaves a vacuum that needs to be filled. Below, the cooler air begins to move toward the center of the system, creating a circulation cycle. This movement becomes the core of what is known as low pressure. But it's not just about temperature. The rotation of the Earth also plays a crucial role in hurricane formation. Did you know that this phenomenon is called the Coriolis effect? The Coriolis effect is like a spinning top. When the warm air rises, the cold air moving toward the center does not move in a straight line but curves. This causes the air currents to start rotating around a low-pressure center, forming that characteristic spiral we associate with hurricanes. But what happens when this storm meets land? When a hurricane makes landfall, it loses its energy source. It's like taking the fuel away from an engine. But before that happens, it can wreak havoc. With winds that can exceed 200 kilometers per hour, the hurricane becomes a destructive machine. However, the real danger does not always come from the wind. Rain and storm surges are often responsible for the devastation, flooding entire areas and causing irreparable damage. Now let's think about the life cycle of a hurricane, from its formation to its dissipation. How long can one of these storms last? Generally, a hurricane can live from a few days to more than a week. But what determines its duration? The answer lies in the environment. If the hurricane moves over warm waters, it can strengthen. But if it encounters cold waters or land, its life begins to fade. It's fascinating to think about how many hurricanes form each year. On average, around 10 to 12 hurricanes develop in the Atlantic Ocean, although not all make landfall. But why are some hurricanes more intense than others? The answer to this question can be found in several factors: ocean temperature, humidity in the atmosphere, and the presence of other low-pressure systems. Each of these elements acts like pieces of a puzzle that, when assembled, can create a monumental storm. The science of climate has advanced significantly in recent decades, allowing us to better understand these phenomena. Thanks to satellites and computational models, meteorologists can predict a hurricane's path with greater accuracy. This is crucial as it allows communities to prepare and, in some cases, evacuate before the hurricane reaches the coast. The connection between hurricanes and climate change is also a topic of great debate. As the planet warms, the oceans warm as well. This could lead to more intense and frequent hurricanes in the future. Are we really prepared to face this new reality? The answer to this question is vital, not only for coastal communities, but for the entire world. In summary, Hurricanes are a reminder of the power of nature. From the energy that fuels them to their life cycle, every part of this phenomenon is a testament to the complexity of Earth's climate. The next time you hear about a hurricane in the news, remember that behind that storm is a fascinating process that has been occurring for millions of years. The curiosity about how these giants of wind and rain form is just the first step in understanding our world. Nature, with all its majesty and power, remains a mystery that invites us to learn and explore. Hurricanes are fascinating and terrifying natural phenomena at the same time. We often wonder, what makes a hurricane such a powerful force? How does it form, and what factors determine its intensity and trajectory? Understanding this will help us better appreciate the magnitude of these climatic events. When a hurricane begins to develop, it originates in an area of low pressure where warm, moist air rises. As this air ascends, it leaves a vacuum that draws in more air from the surroundings, creating a continuous cycle of rising and cooling air. But this is where the meteorological magic really happens. The cold air, as it descends, warms up again and generates a kind of gear that propels the hurricane forward. Isn't it amazing to think that a simple change in temperature and pressure can lead to such a devastating phenomenon? Now, not all hurricanes are the same. Some become multi-category monsters while others dissipate before causing havoc. What determines this difference? The answer lies in several factors, including the temperature of the ocean water. A warm ocean acts as the fuel for a hurricane, while a cold ocean can hinder its growth. So when we hear about a hurricane forming in the warm waters of the Caribbean, it's like watching an athlete in full stride, ready to give its best. In addition to water temperature, humidity in the atmosphere plays a crucial role. A humidity-saturated atmosphere provides the energy needed for the hurricane to strengthen. But if the air surrounding the hurricane is too dry, it could weaken. It's like trying to inflate a balloon. If the air you introduce is insufficient, the balloon won't expand. Another vital aspect in the formation and trajectory of hurricanes is the wind at different altitudes. Surface winds must be aligned in such a way that the hurricane can spin and develop without obstacles. If there are shear winds, which are changes in wind speed or direction at different altitudes, these can destabilize the hurricane and hinder its formation. It's like trying to spin a top. If there's a breeze pushing it in the wrong direction, it could fall over sooner than expected. Hurricane season is not an isolated event, but a cycle that repeats every year. But why are there specific seasons for these phenomena? This is because climatic and oceanographic conditions tend to be more favorable for hurricane formation in certain months. In the Atlantic, for example, hurricane season runs from June to November, coinciding with the warming of ocean waters. So each year the ocean becomes an oven, preparing for the creation of these giants. However, despite their formidable power, meteorologists have developed tools to predict the formation and trajectory of hurricanes. Thanks to satellites and computational models, we can anticipate their arrival and take precautions, but sometimes, even the most advanced technology can be surprisingly inaccurate. This leads us to question, to what extent can we trust our predictions for such a chaotic phenomenon as a hurricane? When a hurricane approaches the coast, the pressure on communities increases. Evacuation becomes a priority, but it's not always easy. People must decide between staying and facing the hurricane or leaving their homes in search of safety. How does one make such a decision? What factors influence the choice to stay or go? The intensity of a hurricane is not only measured by its category on the Saffir-Simpson scale, which ranges from 1 to 5, but also by the effects it has on the areas it touches. From strong winds and torrential rains to storm surges that can flood entire regions, hurricanes are capable of causing massive destruction. The images of devastation they leave in their wake are a reminder of the power of nature and our vulnerability to it. After a hurricane passes, communities must face recovery. But what does it really mean to rebuild after a disaster? The answer is not simple. Recovery can take years and often involves dealing with the emotional trauma of those who have lost everything. Stories of resilience emerge. But questions also arise about how we can better prepare for the next hurricane. Amid this struggle, science continues to advance. Researchers work tirelessly to better understand hurricanes and how climate change may be influencing their frequency and intensity. Are we seeing an increase in more powerful hurricanes? Each new study adds a piece to the puzzle, but much remains to be discovered. Finally, it is vital to remember that hurricanes, while devastating, are also part of the planet's natural cycle. They distribute heat and moisture in the atmosphere, balancing the climate in various regions. So while their impact can be destructive, their existence serves a purpose in the grand scheme of the Earth. So the next time you hear about a hurricane, reflect on its complexity. Each storm is a reminder of the power of nature, the interconnectedness of the elements, and the need to be prepared. Science provides us with tools to understand and anticipate. But nature will always have its own course, and we, as humanity, must learn to coexist with it. Hurricane Katrina became a name that will resonate in history. But what made it so devastating? To understand the magnitude of this natural phenomenon, we must delve into the details of its formation and the impact it had on the southeastern coast of the United States. Imagine a storm that not only brings rain but carries the force of thousands of freight trucks. That was Katrina. In August 2005, the weather system that would eventually become Katrina began to form over the Atlantic Ocean. How is it possible for a simple accumulation of clouds to transform into a fierce hurricane? The answer lies in the ideal conditions that allow a hurricane to gain strength: warm waters and abundant humidity. In this case, the warm water of the Gulf of Mexico acted as the fuel that fed the storm. As Katrina intensified, it became a Category 5 monster, with winds exceeding 200 kilometers per hour. Imagine a tornado swirling over a vast ocean, but much larger and with an immense range of destruction. How do we measure the strength of a hurricane? We use the Saffir-Simpson scale, which classifies these phenomena on a scale from 1 to 5, with 5 being the most devastating. Katrina not only reached that category, but maintained it for an alarming amount of time. The day it made landfall, August 29th, the images that reached our homes showed a city in chaos. But why was New Orleans particularly vulnerable? The answer lies in its geographical location and infrastructure. The city is below sea level and is surrounded by a system of levees that, although designed to protect, were in poor condition. The combination of Katrina's strength and the weakness of the levees resulted in a devastating flood that submerged much of the city. The effects of Katrina were not limited to physical destruction. This hurricane brought with it a tsunami of social and economic problems. What happens when a city is forced to evacuate thousands of people? The answer is logistical chaos. Many residents were trapped, unable to leave in time. Imagine the anguish of those who, due to lack of resources or information, could not escape the storm. As the waters receded, the aftermath was evident. The loss of life was tragic, but so was the destruction of entire communities. How can a storm change the lives of so many people in an instant? For many, life would never be the same again. Reconstruction became a monumental challenge, and recovery a process that would take years. Katrina also revealed the fragility of our infrastructures and the urgent need to prepare for future disasters. How can we better protect ourselves? Planning and investment in early warning systems are crucial. The lessons learned from Katrina have led us to rethink how we face hurricanes and other natural disasters. Studies on climate change have added another layer of complexity to this conversation. Is it possible that our actions are intensifying these phenomena? Science is beginning to establish connections between global warming and the intensity of hurricanes, prompting us to reflect on our responsibility in caring for the planet. As we explore the legacy of Katrina, it is essential to remember that while hurricanes are natural phenomena, our human decisions can influence their impact. Building more resilient cities and strengthening our response systems are vital steps toward a safer future. The story of Katrina is not just the story of a hurricane. It is a reminder that nature is powerful and unpredictable. Every time we hear a storm forecast, we must remember the force that can be unleashed and the importance of being prepared. In conclusion, Hurricane Katrina not only left marks on the landscape of New Orleans, but also on the collective consciousness about the importance of disaster preparedness and response. Learning from these events is essential to mitigate the impact of future hurricanes. Will we be ready for the next storm? Only time will tell. Tornadoes are fascinating and at the same time terrifying natural phenomena. How is it possible for a simple cloud to transform into a devastating whirlwind? The answer lies in the complexity of the atmosphere and the interaction of different climatic factors. A tornado is like a giant ballet dancer, spinning and twisting in a chaotic dance, but always with a purpose: to seek the energy that fuels it. When storms form, warm, moist air rises rapidly while cold air descends. This upward movement is like a pot of boiling water. The steam wants to escape, and as it accumulates, currents are generated that can lead to the creation of a tornado. But what happens when these currents meet? That's where the magic, or rather the physics, comes into play. If warm air encounters wind coming from the opposite direction, a rotation can be generated. Imagine a skating rink. If a skater pushes their body in one direction while spinning, they can rotate faster. This is the principle behind tornado formation. The combination of winds swirling in opposite directions creates a funnel that extends from the cloud to the ground. But not all tornadoes are the same. Some are barely a breeze compared to others, which can be devastating. What determines the intensity of a tornado? The key lies in the amount of energy available in the air. The warmer and more humid the air, the more energy the tornado has to grow and intensify. It's as if the tornado is receiving extra fuel that allows it to increase its destructive power. The relationship between tornadoes and climate change is a topic of ongoing debate. As the planet warms, the air becomes more humid and hot, which could increase the frequency and intensity of these phenomena. But is climate change really affecting tornadoes? While science is still investigating this connection, some studies suggest that yes, global warming could be altering the climatic patterns that give rise to these storms. In the past, we have witnessed tornadoes that have left indelible marks in history. One of the most devastating occurred in 1947 in Texas. The city of Waco was devastated in a matter of minutes, and over 100 lives were lost. How is it possible for a natural phenomenon to cause such destruction in such a short time? The answer lies in the speed of the winds, which in some cases can exceed 300 kilometers per hour. But it's not just about wind strength. The path of a tornado also plays a crucial role in its impact. A tornado that moves through rural areas may cause much less damage than one that traverses a densely populated city. Urban planning and how communities prepare for these events are crucial to minimizing damage and saving lives. Technology has advanced significantly in the detection and prediction of tornadoes. Nowadays, meteorologists use radar and satellites to study atmospheric conditions and issue alerts. However, despite these advances, there are times when tornadoes appear without warning. How can we be better prepared to face these challenges? Education and community preparedness are essential. Knowing the signs of a tornado and having an action plan can make the difference between life and death. The myths about tornadoes are also interesting. Many believe that opening windows in the house can help equalize pressure and prevent them from breaking. However, this is not only ineffective but can also be very dangerous. The truth is that the best thing to do is to seek shelter in a safe place, away from windows and doors. The history of tornadoes is not only focused on destruction, but also on the resilience of communities. After a disaster, many cities have reborn, rebuilding and strengthening their infrastructures. This spirit of overcoming is a testament to human capacity to adapt and face adversities. It is fascinating to think about how such a powerful natural phenomenon can be a mix of beauty and destruction. Tornadoes remind us of the strength of nature and the vulnerability of our existence. As we admire the complexity of the climate and its effects on our world, we must also consider how our actions can influence these phenomena. Research continues, and each new discovery brings us closer to unraveling the mysteries of the atmosphere. Science progresses, but there are always more questions than answers. What does the future hold for tornadoes and other natural disasters? Curiosity is the first step toward knowledge, and it is essential that we continue exploring and learning. Ultimately, tornadoes are a reminder that while we may try to predict and control the weather, there are forces in nature that are greater than us. As we continue to observe the sky and weather patterns, we must never lose sight of the importance of being prepared and educated about these phenomena. Only then can we face the unknown with courage and knowledge. What will happen to our planet in the future? It is a question that worries and intrigues us, and the answer is not simple. As time goes on, Earth faces significant challenges that could change the way we live and how we interact with our environment. To understand this, it is helpful to imagine Earth as a large machine where each part, from the oceans to the atmosphere, plays a crucial role in its functioning. But what happens when one of those parts begins to fail? Scientists have started to study the climate and how it is changing at an unprecedented rate. Global warming, driven by human activity, is one of the most concerning factors. As we burn fossil fuels and release greenhouse gases, the temperature of our planet rises. But what does this really mean? Imagine putting a pot of water on the stove. At first, the water is cold, but as you turn on the heat, the temperature starts to increase. If you don't control that heat, the water will eventually start to boil. This is how Earth is reacting to our actions. In the coming years, we are likely to see an increase in the intensity and frequency of extreme weather events. Have you ever wondered why some places seem more prone to hurricanes or droughts? The answer lies in how the climate changes and adapts. Hurricanes, for example, need warm water to form. With the warming of the oceans, these phenomena are expected to become more powerful. Imagine an extreme sport where competitors become increasingly daring. In the same way, hurricanes are becoming more ferocious. Drought, on the other hand, is like a plant that does not receive enough water. As the climate warms and rainfall becomes less predictable, many regions face water scarcity. This not only affects people but also ecosystems that depend on a steady supply of water to survive. But what will happen to agriculture? If farmland does not receive enough rain, food production will be threatened, potentially triggering a global food crisis. One fascinating aspect of Earth's future is how humans are responding to these challenges. Innovation and technology are playing a key role in the fight against climate change. From renewable energy to sustainable farming techniques, there is a growing effort to find solutions that help us adapt and mitigate the effects of our impact on the planet. Can you imagine a world where cities are greener and energy sources are clean? That is a possibility we are already beginning to explore. However, not everything is optimistic. Species extinctions are a grim reminder of the effects we have on the planet. More and more animals and plants are disappearing due to habitat loss and climate change. This not only affects biodiversity but also undermines the health of the ecosystems we depend on. Reflecting on the future of Earth is also about thinking of the future of all forms of life that inhabit it. As we look ahead, it is crucial to ask ourselves, what legacy will we leave for future generations? How we respond to today's challenges will determine the kind of world our children and grandchildren will inherit. Every action counts, from reducing plastic use to opting for public transportation. It is a collective effort that requires everyone's participation. Climate change is not a distant problem, it is happening right now. The consequences of our decisions are felt in every corner of the planet. However, there is hope. As awareness of these issues grows, so does the willingness to act. Communities are coming together, young people are raising their voices, and businesses are re-evaluating their practices. Could it be that we are on the brink of positive change? The science of climate is complex, but its message is clear. We need to act. Every effort counts. And although the road ahead may seem daunting, collaboration and innovation can make a difference. In the end, the future of Earth is not set in stone. It is in our hands, and it is up to each of us to decide how we want it to be. Ultimately, reflecting on the future of our planet is also an invitation to hope. Although we face significant challenges, we also have the capacity to adapt, innovate, and find solutions. Imagine a future where we live in harmony with nature, where future generations can enjoy a vibrant and life-filled planet. That vision is within reach if we are willing to work together for it. So what path will we choose? The answer will not only determine the future of our planet, but also the legacy we leave behind. The story of Earth is a story of transformation and resilience, and in this chapter, we are the protagonists. Mass extinctions have been dramatic events in the history of Earth, moments when life, as we know it, has faced nearly insurmountable challenges. To understand the magnitude of these events, let's think of a great storm sweeping through a forest. During that storm, many trees fall, and the vegetation is severely affected. However, in the end, the forest can regenerate and bloom again. But what if that storm was so intense that it wiped out everything we know, leaving only a small fraction of life behind? Over the last 500 million years, Earth has experienced 5 major mass extinctions. The most well-known of all, which ended the dinosaurs, occurred about 65 million years ago. But what caused such a catastrophe? Some scientists point to a massive asteroid impact as the main culprit, while others suggest that climate change and volcanic eruptions also played a crucial role. It's as if a series of events triggered a chain reaction, altering the balance of life on the planet. Thinking about the extinction of the dinosaurs leads us to wonder, how did this affect other species? The answer is fascinating. After the disappearance of the giant reptiles, mammals began to expand and diversify, filling the vacant niches. Thus, the mass extinction not only eliminated species, but also opened the door to new forms of life. It's as if one door closed, but another opened, allowing new ideas and forms of life to flourish in the world. One event that is often overlooked is the Permian-Triassic extinction, which occurred about 265 million years ago. This was the most devastating event of all, where it is estimated that more than 90% of marine species and more than 75% of terrestrial species went extinct. Imagine a world where almost everything you know no longer exists. What if everything we love suddenly disappeared? This event makes us reflect on the vulnerability of life. Throughout history, extinctions have been driven by various factors: changes in climate, massive volcanic eruptions, changes in sea level, and even human activity. Could it be that, in our pursuit of progress, we are writing a new chapter in the history of extinctions? The extinction of species is a reminder that we are all connected in a complex web of life. Every action we take has an impact on that delicate balance. But what do these extinctions teach us about our own future? They show us that life is resilient, but they also warn us about the dangers we face. Often, when a species disappears, it takes with it a part of Earth's history, a chapter that can never be rewritten. How do we prevent our species and others from disappearing in the same way? The answer may lie in how we care for our planet and how we make decisions about our environment. Scientists have begun to study extinction patterns and their relationship to current climate change. The question that arises is unsettling. Are we in the midst of the 6th mass extinction? If we continue habitat destruction and pollution, we could be pushing many species to the brink of extinction. Earth has undergone great transformations, but now the speed of these changes is alarming. Are we really prepared to face the consequences of our actions? It is important to remember that extinctions are not just numbers in a report, they are stories of life. Each species that disappears carries with it a legacy, a set of genes and characteristics that will never return. For example, the dodo, a bird that once inhabited the island of Mauritius, went extinct in the 17th century due to hunting and the introduction of invasive species. Imagine a world where such a unique being no longer exists. It is an invaluable loss. In this context, we must ask ourselves, what can we do to change the course? The answer lies in conservation and education, protecting habitats, reducing our carbon footprint, and supporting initiatives that promote biodiversity are crucial steps. If each of us made conscious decisions, we could help preserve the richness of life on our planet. The story of mass extinctions reminds us that time is a limited resource. Whether we talk about an asteroid impacting Earth or our daily actions, every decision counts. Just as the forest can regenerate after a storm, we too have the opportunity to heal our planet, but we must act now, before it is too late. Thus, as we look to the future, it is essential that we remember the lessons of the past. Each extinction tells us a story and offers us an opportunity to reflect on our role in this vast universe. The history of life on Earth is a continuous thread that connects every living being, and it is our responsibility to care for that thread for future generations. The question that remains is, are we ready to face this challenge and ensure that life on Earth continues to flourish? The vastness of the universe is a stage filled with mysteries and wonders that invite us to reflect on our place within it. Throughout our history, we have witnessed astonishing phenomena and unraveled secrets that have led us to question who we are and where we come from. What role do we play in this immense cosmic work? Are we merely an accident in a vast sea of stars, or is there a purpose behind our existence? The history of the universe is an epic narrative that spans billions of years. A tale that begins with the Big Bang. But what does that really mean for us? As we look up at the sky, we confront questions about time, space, and matter. The idea that everything we know, from the smallest grain of sand to the farthest galaxies, originated from a singular moment is undoubtedly a fascinating concept. How does that translate into our daily lives? As we delve into this narrative, it is essential to remember that we are part of an endless cycle. Earth, in its orbit around the Sun, has been shaped by cosmic events and climate changes that have defined its history. And just as Earth has changed, so too has life on it. What does that mean for the future of life on our planet? The question resonates in every corner of our existence. The mass extinction events that have struck our planet have left indelible marks on how we understand life. Each extinction has been a chapter of transformation, a call to adaptation. What lessons can we learn from those critical moments? The answer may be a reminder of our resilience and capacity for adaptation, but also a call to the responsibility we have towards our environment. In this vast universe, the search for life becomes a recurring theme. As we gaze at the stars, we wonder, are there other beings like us seeking answers in their own corner of the cosmos? The possibility of life on other planets, especially those that could harbor water, ignites curiosity and imagination. Could we one day make contact with them and share our stories? Earth, despite its fragility, is a unique place, an oasis in the immensity of space. However, climate change and alterations in our weather patterns make us question how much time we have left. Are we in time to change course and protect our home? The answer to this question may determine the future of the coming generations. Hurricanes, tornadoes, and other natural phenomena serve as reminders of nature's power and our vulnerability. Often they make us feel small in the face of the vastness that surrounds us. But could it be that these events also have a purpose? Perhaps they teach us about the interconnectedness of all elements on our planet, reminding us that every action has a reaction. When we contemplate the future of Earth, we also face the question of hope. Can we imagine a world where we learn from our mistakes and work together for a more sustainable future? History has shown us that humanity is capable of great achievements, but also of great failures. The key lies in finding a balance. Reflecting on our place in the universe not only invites us to look outward, but also inward. What values and principles will guide our decisions in the years to come? The connection between science and philosophy becomes evident as both disciplines seek answers to the same fundamental questions. As we embark on this quest, it is crucial to maintain an open mind and a heart willing to learn. The universe, with its vastness and complexity, is a constant reminder that we are part of something much larger. Often we get lost in the details of our daily lives, forgetting the wonder that surrounds us. The invitation is to look up at the sky and remember that curiosity and awe are powerful tools that drive us to keep exploring. Ultimately, the journey through time and space leads us to one conclusion. Each of us, in our uniqueness, has a role to play in this vast cosmic symphony. The connection between all living beings is a thread that weaves our stories together, and it is our responsibility to care for our planet and for ourselves. The final reflection centers on hope. As we look toward the future, it is possible to imagine a world where humanity, having learned from its past, chooses a path of collaboration and respect, a future in which science and the heart work hand in hand, where knowledge guides us toward a brighter destiny. The question remains, are we ready to embrace this challenge? The search for answers and the exploration of the cosmos will never cease. In the end, the most important journey is the one we take inward, toward our essence. What legacy do we want to leave for future generations? The story of the universe continues, and we are a vital part of that narrative. Let us remember that each star in the sky is a witness to our existence and a beacon of hope in the darkness.